So yesterday we cover basics about the virtual threads, right?
Right.
Virtual thread, and now highly recommendation from the Java ecosystem. Yeah, sons, uh, Java designers, please try to use this new feature, virtual thread, now available for the all developers since JDK 21, right?
Right.
So today we are
Like
going
they are
to,
suggesting. This is
yeah,
they suggest. Okay.
yeah. Today we are going to understand some basic example. We can write the same example using this normal thread or executor service, but let's do some couple of example using the virtual threads so we feel comfortable to using them, right?
Right.
So today our objective, we are also going to discuss about this thread safe collection. Okay, thread safe collection. Okay.
Right.
Thread safe collection means Java already given some library, some classes, which is best suit or you can work fine in the case of multi-threading environment, right?
Yeah.
So couple of example we have already did like producer consumer problems where maybe any shared resources where one thread going to producing some data and another threads going to read data, right? Using the normal thread way we have achieved. So this the data where the threads are going to read, okay, and here this may be your own custom class or array list or any collection framework, right? So
Right.
whenever you are using any collection frameworks, in this case, if you want, if one threads are produce some data, someone must consume that next time they are going to the produce. So here we have to understand something kind of a thread communications or thread synchronization needed. So we have learned about the multiple way we can ensure that this object uh, at a time only one thread can access. If producer is producing at the same time, consumer are not going to consume. If consumer is consuming, producer just wait, right? So
Right.
for that we have understand the synchronize keyword, understand the synchronize method, understand the lock interface, reentrant lock interface, understand the semaphore, understand the executors. Multiple way we have to complete this, right? So for
Right.
as a Java developer, we are going to write this primitive and ensuring that hey, this is the collection, this is the my object, and at a time only one thread can access, right? Or at a time two thread can access. After that, more cannot allow, right?
Right.
So, uh, Java say ki lots of usability about this. So why as a Java designer not given some collection that are thread safe? Thread safe means if this is the collections and one thread try to write data and so another one wait. If there is no data, let's this is my collections and one thread no written any data and I'm going to reading from data. So this would be make sense ki why you are reading data, there is no data here. Please wait. If you get a chance to read data, if you have no data, you automatically have to wait until someone not produced the data here, right? So
Right.
this is manually we have achieved to write the basic about this synchronized keyword or reentrant lock. So those things automatically implemented by the Java library and given some classes. That class is known as a thread safe collections. Okay,
Right.
thread safe collection. So we are going to understand. You can say in the Java 5 onward, JDK 5 onward, multiple thread safe collections are going to added. But before Java 5, if you notice, like our string class is a thread safe class. Okay. Last, whenever I am talking about thread safe, I have given the example how string is a thread safe. Means ki once one string object are created, no another thread can going to update them, no another thread going to modify them, just all of us read them.
Right.
So similarly here we are going to understand today one blocking queue. This is the one of the data structures, or you can say one of the blocking queue. Let's for integer. Okay, queue. Okay. This is the one of data structure. You can say one of the queue. They are support by default uh, locking, unlocking, ensuring that key. If our queue is empty, no one can read. If you have a data, then someone writes. Right. These concept synchronization implementation, reiterate lock implementation, ensuring the concurrency, all the problem is already taken care. As a Java developer, if we know there is already some collection like this, then we can use them, right?
Right.
So blocking queue is an interface. Okay. So first blocking queue is a thread safe collection. Okay. Thread safe collection. Collection means they are providing to store or get list of value, one value, two value, 100 value, right?
Yeah.
And blocking uh, collection is an interface. Okay, interface, and you can say blocking collection, blocking queue can be in the two form, two, two form. One can be bounded blocking
Yeah.
queue, and one can be unbounded.
Right.
I'll explain what the meaning block bounded, unbounded. As you might be, whenever we are studying now, this is the queue concept. I think we have not discussed till now, but just like we have understand the list, right? Right?
Right.
List is the data structures where, as a Java developer, are going to add any number of element, one element, two element, three element. Later can read one element, two element, three element, four element, right?
Right.
Similarly, queue is also kind of one data structure. Okay, data structure say queue means just like you are going to the airport or you are going to the railway station, you are going to the booking counter. You have to maintain some queue, right? To
Right.
take your turns and get the data, get the services, right? Let's say go to the booking counter and we have only one booking counter. First person go and put in the queue, second queue, third queue, fourth queue. Whenever counter open, first go to the serve and go out. Second go to the serve, so out, right? So this the kind of concept means ki here also the collections of peoples. Similarly, here queue means set of peoples arranging in particular order, right? So that in a particular order they can get the service. So here our name as a blocking queue. Blocking queue means there is some collections. There is some set of object. Here collection means set of integer number, set of float number, or set of object, set of employee, any kind of, right?
Right.
Any kind one
Right.
employee maybe or 10 employee, right? Or one numbers or 10 number.
Right.
Okay, so this is the queue. But why say this is a blocking queue? Because they support you can allow if there is a no object in this queue. If someone thread come, hey, I want to read data from here, but this queue have a no any data, so this thread automatically going to wait until some thread come and put new data here. If let's say I put something here and this automatic notification game and this thread can read data. So this, due to this you can say this is the blocking queue. Blocking queue means they have some kind of a special feature where if there is a no data and consumer thread, yeah, reader thread come data and try to read, and there is a no data at that time, our reader threads or consumer threads are going to just wait. For that, as a developer, I'm not going to write any wait method, asynchronous method, a lock method, right? They are internally implemented it, right?
Right.
Similarly, let's see, I have a say, in my queue, have a only capacity of 10, okay? 10 capacity. Means ki if we are going to the put one number, it's okay. Two number, it's okay. Three number, it's okay. Let's see, we put the already 10. And after this, again, I'm going to the put new number. But my capacity full. So blocking queue, hey, you wait because our capacity is full. You cannot write more data here because our capacity is full. I have only capacity of 10 and you are already written 10 and just wait some new threads come that consume data, then you are able to, then you get notification, hey, queue have some space, let's you write them, right?
Right.
So these two functionality like waiting for a writer, yeah, waiting for reader, automatically by default implemented class internally. So as a Java developer, just we use this library and get this benefit. So here notice I talk about the capacity. Capacity means ki whenever we are say ki our queue have a uh, capacity of 5, capacity of 1, capacity of 7, number of whatever the element you are going to store in the queue. If such queue known as a bounded queue, known as a bounded queue. The queue have a foundation means ki queue with a capacity, right?
Right.
So might be I'm interested ki my queue have only maximum one data can allow. If no more than one, I can say please wait because someone cannot consume them.
Right.
Our bounded capacity 10 or 100 or 1000. That whenever you define capacity, that means known as a bounded queue. Known as a bounded queue. Correct?
Right.
Bounded queue means set capacity, set initial capacity, right? So this is the bounded. Unbounded means developer. I don't know how many element I am going to add. I have not remembered. Yeah, initially I don't know. That means we are not setting initial capacity. Means not set any initial capacity, right? So such queue known as a unbounded queue. That is clear. So whenever say bounded queue means you are going to the set some capacity of this queue. Maybe this is the three element. So only three element can put here and only three can get one by one. But in the case of unbounded, you are not specifying any size, then by default it will going to this some maximum range. So what maximum range? Integer dot max length. So by default, bounded capacity means a south, let's say integer class dot max value. This is the maximum capacity by default our JVM applied. That means this number. Okay, this is very huge number. Notice. Okay, so this is your default capacity. If you're not specify anything, by default compiler assume ki such number of element this queue can hold. Okay, so till now it's clear.
Yeah.
Any confusion? What do you mean by bounded capacity? Means you can specify some initial value, initial capacity. Unbounded means you are not specifying anything, but anything means infinite. But in the computer system, there is a no infinite number, right? In the real
Right.
life, you cannot find out the maximum number, right? What is the maximum number of integer? 1, 2, 10, 100, 1000. Till now, there is no one can found it, right? You can add
Right.
plus one, add plus one, add plus one. This is infinite. So whenever we are going to implement some software, we have to define some boundary, right?
Right.
Java language what decided if for integer number they have it till now set at the one maximum value. Okay, maximum value this. Okay,
Oh, so that's the maximum value.
as maximum. This number of element are object you can store in this queue, right?
Right. Right.
Great.
Yeah.
But uh, you can do more. You can also do like infinite. You can do. So surely till now, again we have some kind of things we have not covered. Like till now we have only understand, read, study data structure like array. Array have a some kind of size index. Notice the index of 0, index of 1, index of 2, index of 3. This is the integer value, right? Integer value.
Right.
Integer value maximum range of this. So whenever you are going to create any array, that maximum value can hold this, right? Because this is the maximum length of integer. Because any value you are going to add the index, you cannot go to the beyond the index, right?
Yeah.
So this is the one of the challenges. Uh, but if sometime, let's in a real life, you want more than this, I want to put, right? So so for that, in a Java, or you can say computer science, a data structure, we have implemented two kind of collections. One is the sequential collection, one by one, right? One by one after one after one after. Another is a non-sequential data structure. This is the one data structure till now we have studied, like array data structure. Many example we did. But another kind of data structure known as a non-sequential data structure. Non-sequential. This is the sequentially one after one after one after by index, right? This is known as a non-sequential data structure. This is also considered as a linked list. Okay, linked list. Till now we have not studied, but surely the one of the topics later, whenever I have times, we'll discuss non-sequential data structure. So what the concept of linked list? Linked list say कि this is a one node and add number, one number add. I just link to the next number here link. What is the next number? Next number link here. We have next number link here. So we are going to the link one number to the previous number. And whatever the you in your computer have a number of space available, okay, accordingly you can store any number of element here in the linked list,
Right.
right? Because linked list have not any fixed required any index. Index means integer number. That means maximum index would be the your integer maximum number.
Right.
So the for those scenario, generally we are using the non-sequential data structure, that is known as a linked list. Means ki one number and what is the next number? Whatever the memory space available, you can store and link this the previous number by this. This is the next number. What is the next number? Next number can be. Next number can be. Okay. Next number can be. Next number can be. You can add infinite next, right? There is a no limitation, right? This is the basic concept about might we learn about the blockchain. Nowadays, notice the blockchain is very popular technology. Blockchain. You know what is the blockchain? We'll discuss. Maybe you have a time read. This is the concept of nowadays blockchain, Bitcoin. Have you understand? Bitcoin, blockchain, lots of buzzwords nowadays going on, right? So all these things are implemented in the concept of this linked list, non-sequential data structure. So we are going to the off our topics. Okay, let's come on the topic. Right, we'll discuss. Okay, so let's tick. So I say ki bound our queue is the interface. Then how I can use them? Right. This is the our interface. See the our interface. So my question: how I can use this interface? That means for use we need the some implementation class. So for this two implementation class we have. Implementation class one is your new array data structure implementation I discuss, and here you can give some initial capacity. And another implementation you have, maybe another implementation. Second implementation is the linked list data structure. Okay, linked list blocking queue. Right. So as of now, this blocking queue you can get in a both data structure as a sequential data structure means array blocking queue or non-sequential data structure like a linked list, yeah, list blocking queue, right? So notice this array blocking queue always need a capacity. Without capacity, you cannot create the array blocking queue. Means कि they are expecting you are going to create array, and notice whenever going to create array we needed required some initial capacity. What is the number of element you are going to store in array? Maybe 1, maybe 2, maybe 10, maybe 100, maybe any number. So at least whenever you are going to make any queue that for finite number, array blocking queue always say, hey, give me some number. Maybe here initial capacity, here I can say 5. That means this is our bounded queue. This is known as your bounded queue. This become your bounded queue, right? And this become your unbounded queue. Here, so this is the two implementation you can going to use for this blocking queue. Maybe array blocking queue or maybe linked list blocking queue. As a array means they are internally going to create one array for your sequential means each elements are going to stay at the index position means 0 position, 1 position, 2 position, 3 position, 4 position, 5 position. Due to that they pass the initial capacity, the number of items you are going to store in this array blocking queue. Second data structure is the linked list. Here you cannot specify anything, or you want, you can specify. Both here have options. So here unbounded queue, you cannot specify anything. This is a default capacity with the integer data max length. But you want to specify some capacity. So here you have options. You can say, hey, this is my bounded capacity with the capacity. With the capacity. Capacity here say I am going to 10, right?
Yeah. Yeah.
Both we have option. This linked list data structures, you have a both option, unbounded queue or the bounded queue. That means linked list is the data structure where if you not specify anything, so they are going just going to create initially with just one blank object. Say he say, hey, put new, so they are going to link to the here. You can say add one more element, they are going to link to the here. Add one element, they are going to link here. Add one element, link to the here. In this way, in finite number of element, you can just link to each other, next to next to next to next to next to next to next, until the number of memory you have. Maybe one system, maybe different system, different. Nowadays, due to the cloud infrastructures, you can use that across the system, right, to maintain this kind of link, yeah, chain between one object to the previous object. This is a chain of one object to another object, one object to another object. What is my previous? I can know. What is my previous? I can know. What is my next? I can know. Right? So this is the chain. Chain. This is all you can say. Node or object is the due to this similar the new technology concept known as blockchaining. All the blocks are chained to each other. Right? So internally, surely we're going to discuss about the linked list data structure or non-sequential data structure. As of now, just understand this is the two kind of data structure. One is a sequential, one is a non-sequential. It's clear? Uh, so let's good. Let's this is the collections. These collections are thread safe. You can use. So let us write one simple example using this queue, blocking queue, a queue concept where we can ensuring that really they are blocking to me or not, or really they are giving some data or not. Let's good example. So I am just create a simple blocking queue, blocking blocking queue of let's say integer queue and uh, new let's array implementation. And just here I say initial capacity just one, right? And let's here I am just going to print them as out, print them. This automatic this will print them, and by default this will be. And what happened? I am just uh, let's I want to uh, for adding data we have function you can use the put. Okay, put function, put number. Maybe I want to add number 23, right? So after notice this put methods are uh, throwing exception because they are using the blocking concept. If okay, so we have to use the try catch or handle the method signature. And after that again you put here, and that you're getting data. If you run here properly, we are able to create the one blocking queue and putting the value and getting one value. What
Right.
happened? Let's say we have defined one my queue that have a capacity only one. If I already put one, right here I put one. Okay, let's say I put another one. Then what happened? As per the theory say, this blocking queue not allow we can put more. We can say new threads, new requests. Please wait until someone not read them, right? Because your capacity is one. So let's try. Here notice, here I am getting the both object because 23, 23. Before let's say I am going to the put one more 24, right?
Right.
As per the theory, these put methods are going to wait because there is no capacity, right? So let's test. If you are going to use this put methods and notice our thread is waiting here, our main
Right.
thread, because we are not writing any multi-threading, that means a main thread. So main threads are just waiting because you already here your queue is a full because your queue capacity is only one.
Right.
So this is infinitely waiting until someone going to read this value, right? This is the one use case here. That means our blocking queue properly work. If our capacity is full, they are not going to allow new threads or new requests to entertain. Just say ki wait. Now this application wait infinite because some new threads, yes, someone come and read this well, right? That means that's our use case like here. Let's keep producer produce the data, right? And
Right.
let consumer is not consumed till now. Producer again try to produce data, he will wait because this data is not consumed by any consumer, right? So this
Right.
scenario that means they indicate they are implemented properly, right? Good option. So let's manually stop them and comment out. So here what happened? Let's I am going to consume data. So here how to consume data means queue dot take. Take is the method which give me the that's out. Okay? So now here after putting
Arjun bhai,
uh,
just 1 minute, hey? One
yeah.
minute.
Yeah, come.
Yes.
Good. That's very good documentation in Java doc here. Just I'm reading in the case of waiting. Just suddenly I keep our mouse here. The very good Java doc available here. I'm just reading. That is very interesting. Okay. So let's give example. This is whatever I am speaking you already written in this Java doc. Okay. Just move your mouse here. Already written your blocking queue. Okay. This is a block operation. Which operation? Why I am getting the only put and take? Because this is the block operation. They support you can block. If you want to kind of non-block operation, you can use the add, remove, or element. These are the insert operation. These are the remove operation. These are just exam in printing the value, right? So these queue have a lots of operation like add, or offer, or put, or offer with the timestamps. So read this Java documentation. Already good exam explanation. Whatever I'm explaining here for the bounded queue already written in this Java documentation, right? And what kind of operation you can do here. Why I'm using the only put and take, right? Because this documentation mention put is used for the block operation. Means if your queue is full, your request is going to the block. Take Take is the operations when your queue is empty, by default your request is going to the block. Okay. So let us here example. I am going to use a take, and if I'm running, you notice I am able to one put and one get. Our application properly run one put, one get, and block. What happened? I go again try to take next time. Means one already I am printed. I am going to print next one again. This is a take is a blocking. That means our after that our queue should be empty, right? After
Yeah.
that, your good queue should be empty. So this next, this is the uh, first first take, and this would be the second take. Second take. So let's run. So as per the if queue is empty, take operation is going to wait. Notice now first queue empty, we put data and we get data. Queue is empty, and notice the second take is not getting because our application is waiting someone go put some value here, right? Until someone not putting, how take can going to take data, right? So
Right.
second scenario of the blocking queue also proved if there is a no data here, no data, if I'm trying to take, this request is going to wait until someone not going to write data. So this
So it doesn't
application,
go empty. It doesn't go empty database.
yes, here queue is empty because first time I put 23, and after that I take means I can get out. So I can take, then it's become empty, right? And after
Right.
that I'll tell you, hey, get me data. So take is a blocking call. So even let's say I stop this thread, hey, and even I can say I'm not putting any data. I'm not putting any data. Let's say I try to just take here first because this created queue. There is a no data, and I'm to trying to get a value. So our application after this line must going to block because in this queue till now there is no data, right? Run our application print this empty queue empty, and after that we are going to the take data. But this operation say this queue is empty, I am going to read data something here. Take means reading data, and notice this queue is empty, so our thread are going to wait,
Right.
right? Yes. Any confusion till now?
So take will give you empty result if the queue is
No,
empty.
take is not getting any result if your queue is the empty. I am going to call, hey, take data, but this is the empty. That means our this request going to the wait. Notice this, I am not getting this output, right? Because this take is expecting if some data available, then I can take. If no data, then I have to wait.
Right, right.
They are waiting until someone new threads come and write data here. If someone
Mhm.
write data, here ready and again read them,
Right,
right? So this two operation, take and put, is helping to uh, you can say make a thread synchronization, right?
right.
And one thing, this I just reading the documentation say blocking queue are not support. You cannot write any null value here, right? So here, if you're trying to put some null value, let's see, someone say, why not this take method return null if nothing, right? Because this blocking queue support, you cannot. I'm not going to allow to put any null value here. They are not allowed. If you run, this will throw null pointer exception because they are expecting the particular value. Notice you are getting the null pointer exception, right?
Right,
So here you always put the some value, right? Because someone is expecting some value, right? So, so it's not allowed. These are the some kind of a summary. Whenever you are going to use this blocking queue, automatically you can get thread weight and notification concept. Okay, so
right,
here only main thread is running. Due to that, our application is hung, right? So let's the use case. I am going to not run main thread. I am going to say this is my blocking queue, the size of one initial capacity, right? And I am going to start two thread. One thread is the producer thread, one is the consumer thread, right? Producer going to produce data, and once producer produce, then consumer can consume data, right?
right,
If consumer take a first chance and try to consume, they have to wait, right? And if producer already produced data, next time again try to produce, they have to wait because someone not consumed them, right? So this
right,
a producer consumer problem, we have a taken multiple example because this is a very common use case and easily understand. So let's implement this here, right? Without waiting, without synchronization, just use the thread safe collection. This is the queue, right? So as usual, how to write a thread? Maybe good option. You can write multiple way. Implement runnable. So let's write simple class producer. Basic example. Implement runnable. You do runnable, callable, or method reference. Anything you can do, right?
right,
You have your own choice. So implements. Okay. So producer, what say? Just producing some data, right? Producing data where? And consumer just consuming data, right?
right,
Consumer. So producer consuming, that means ki both need this queue. Both need this queue. This producer going to write data here and consumer going to consume data here, right?
right,
So let's here this producer thread, consumer threads, and how as of now, I can just comment out all the things, right?
right. So we're gonna put it in a real example.
Yes. Now I'm going to use the multi-threading here, right?
Right,
This is the just for method reference ki what method doing really work or not. Now let's a real example, right? How
right,
producer consumer we can implement using the blocking queue, very simple way, right?
right,
So let us say here out simple say producer, yes, what data, let's say they infinitely, let's give while loop, they are producing some data, right?
right,
I have now just say let's 1 minute s out producer, just 1 minute, step by step, right? It's the consumer. This is just simple line of it. Till now, this is simple one liner. Producer producing, consumer consuming, right?
right,
And first things, how this is the just code, right? This is the code I want to run in the separate thread. Maybe you can write in the method reference anything, right? So question is that where how to start thread. So surely we already know new thread dot start, but we are already know virtual threads. So let's look the virtual threads. Okay. So I'm say, hey, thread class, I'm going to start off a virtual thread and dot start. What you want to start? Want to start the producer. So let us we have a producer, the producer, right? This is my
right,
producer, okay, and this is my consumer, okay. This is the two class, and here say this is my producer class. Let's start, right?
right,
And similarly, maybe consumer. So this is the way we are using the virtual thread concept, right?
right.
Producer start, consumer start, and yesterday say notice whenever let's see yes out main done, right? In- done. If you run, notice two threads are start, producer and consumer. So notice I'm not getting this output, producers and consumer, right? Why?
Right.
Because main thread is completed before then our thread get a chance. So what I have to? I have to say, hey main, wait some for times, or you can say, hey, I'm going to join here, right? So both we
Right.
have options. So let's say, hey main thread, can you wait so that these two threads can be completed, right? This way. So here say, hey, uh, or you can simply say this thread taken a variable, right? You have a one option. Just join. This is the one another option. Just say join. This means here I am telling main. Can you just join for both? Means until both are not completed, you cannot complete the main done, right? So we have a two option. You can either join method on this virtual thread itself. Now producer and consumer both are done, right?
So why it was not run before?
Because these are the from here two threads are started, right? And
Yeah.
after that main have a don't tell you to do main going to complete it main done. But if your main done, your program is terminated, right? So we
Hmm.
have to say, hey main, wait at least two not completed, right? Or you can use the join one option, or you can simply say, hey main thread I'm just say thread sleep dot wait couple of second, maybe duration of maybe 10 second, right?
Right.
So just main is waiting. In this way you can do. So here you know don't need a join method, okay, both option. And notice now both are threads running. So let me print here some thread name plus thread dot current thread dot get name, okay. And similarly here, so here notice there is a, if you run this yesterday I'm running code, I'm just yesterday you are not informing, I'm getting our thread is name is nothing printing, no thread name. Notice here
Right.
why? Because this is the virtual thread, and might be main thread are doing the same work, or any thread, maybe two thread not started, only one thread can work for you, right? So
Right.
here you have to set your name. So this is the my name. Oh, this is the my producer thread. Producer thread. You can set your name, right? This is the
Right.
consumer thread.
Okay.
You can set your name because I want to set my name. Even you remember thread class also there you can set your name. If you run
Right.
after that you notice this is the return. Give me the thread name. So notice the thread name. Okay. Similarly, one thing we have also thread ID concept, right? Here you can say plus space. This is the one new method. You can say instead of thread name, you can say here thread ID. Thread ID. So by default, thread ID always you can get even name. By default, thread ID is uh, added by the Java virtual thread itself. Okay. If you run this way, you are getting one thread ID as well as. So if you're not setting this name, thread ID always set by the virtual thread, but thread name you can set manually, right? So if let's I'm going to uh, uh, not setting the name here, right? I'm not setting the name. Okay, I'm say just start, right? Option, I'm not setting the name. Okay, and just I commented out. Okay, so if you start this way, the notice here, here just lay, this is the thread name, this is the user thread name. Okay, consumer thread name. Okay, and if you run, you notice we are getting no name. Sorry, no name, right? Only, but ID always you get. So in the case of virtual thread, sometime you notice thread date, current thread dot get name are not getting the name, any name. Why? Because always virtual thread are not going to create any platform thread, right? Might be they are using the main thread itself, right? So due to that, the new concept introduced for virtual thread, always you get the thread ID. Okay, always get a thread ID. Notice for each virtual thread, you are getting the unique thread ID. Notice here 22, 24, right? But you want your application must give a thread name, then you have to set your thread name. So instead of that, you can start your thread using the set name, right? Clear? How to
Yeah.
set name or not name. I for some time yesterday, I started threading this, and I noticed we are not printing my thread name, right? Now thread
Right.
name printing. Good. So let's come out the original problem. So both threads started, both threads are running, but here I'm going to say, hey producer, you can produce data. And where? My blocking queue. This is my blocking queue. I pass here. Okay. I pass to, so that they can add in the constructor. So let's producer why not new constructor? Why not asking constructor? Okay, let I am going to add the constructor. Okay, so this is my constructor. Okay, and this is here
Yeah.
constructor, and just say insert the constructor. Okay, this is the constructor here. Also insert constructor. So this is the way you can pass. Now this producer have a queue, and this is the producer. Then producer just produce some random number. So let us producer say, I am going to say producer dot put. Put let's say I'm going to put some 10 number, right? Or let's example int stream. You can use for loop or int stream dot range. Let's key I want to 1 to 10. Okay, and after
Right.
that I want to for each I am going to just call this. I'm going to call whatever the number we have, say q dot put, and I pass your number. Okay, so now here producers oh yeah, they are need a try catch. Okay, I try catch. So our producer thread just 10 times they are going to produce. Notice this queue have a capacity only one, right? So at
Right.
a time they produce, and whenever going to produce next, they are going to the wait, right? Automatically. Similarly, let's write the code for consumer, right? Here is the consumer. Consumer, what they say? Consumer say, I'm just going to consume data 10 times. So here say simply s out and q dot take,
Take means read.
read, take, consumer, consume, consume, consume data. Okay, consume number.
So it will only read one time because it was mentioned
I
one.
said 10, you got 10 time read.
10
First time
time.
read, if data getting they can read, else they wait. Once,
Okay.
but this will I am saying it, you can try 10 time until 10 number you not getting this thread cannot be closed, right? Here you can
Right.
say while loop, infinite loop, but I am just limit the 10. 10 time I'm trying to say ki this is
Right.
my producer threads, producer producing one and consumer consume one, and
Right.
they wait. And this producer produce one, consumer again consume wait. This 10 time producing producer consumer consume, producer producing consumer consume, producer producing consumer consume.
Right.
Let's producer produce and consumer not get a start. Again try to produce, they are going to wait. So we are ensuring that here producer produce one, let's consumer not started. Producer again going to produce 10 number, they are not going to, they are going to wait until consumer not consume and start producing, right?
Right.
So here say just producer, let's say, yes, say producer produce, consume produce message just given, right? Here producer produce number produced. Okay? Produced. And here just I'm print the queue complete produce. What number produce, right? Produced. So now I can pass this both here. The both thread is started, and let's test. Notice here no any kind of blocking. By default, all the weight synchronization between the threads are taken care by your blocking queue. Just I say, hey, this is a blocking queue for both producer and consumer. And let's run it. So notice here, producer producing one and producer producing and consumer consume one, two, one, two, one, two, one, two, one, two. Finally, so notice this queue have only one time one data, right? No, notice here producer produce one. Okay, and what would be good here instead of writing this way, I can write this message at the top. Where my so that key before producing I write this message. Okay, 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 I'm producing number. Okay, whatever number I am producing number, and once consumer consumed number, then produce give the before producing I just written the right.
Right.
So in this way notice producer produce one and produce one produce uh, and in parallelly you can look the here queue as well as what is the queue plus queue 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 plus queue. This queue always contain only one value at a time. Here you cannot put more than one because capacity is the one. So never this going to put more than multiple value. So in this way, producers are producing only one value in a queue. Notice always queue have a only one. Okay. Notice here producer produce one, queue empty, then producer produce till now consumer already consumed them here the one, right? So in this way, in this way always notice queue have only one value always, right? One value always, one value always.
So producer produce 10 times first and then
No,
consume
no,
10
no, no,
times.
one. Because producer produce only one value one at a time.
Right.
And next time producer cannot produce like a second value with no capacity here to produce, right?
Right.
So until consumer consume one, here producer produce one and then consumer consume one.
Okay. Okay.
Now this become empty, then producer produce two, then consumer consume two, then producer produce three, then consumer consume three, right?
Right.
So
Right.
in this way, here why maybe after producing, let's producer take some time, thread dot
Because
sleep.
we mentioned that it should be one, the capacity.
Capacity always one. So let's maybe just delaying something. Your output can
Oh,
visualize.
put and take. The difference between put and take is one always
No, not always one because I have set capacity here one in the blocking queue.
in the blocking queue. Okay, okay. If
If
you
I
put
say
two,
10, by
if,
default producer 10 produce, right? So in this way, producer producing, consumer consuming, producer producing, consumer consuming, right?
okay, is it after you put something else? You
Just
put
I for output visualization, I can say let's wait for a couple of seconds, right here.
okay,
One
okay,
produce and wait, one produce and wait. So here just add some time, right? So just
right,
output visualization. If you're not writing, quickly you're getting the output, right?
right, right,
So you always say by default this waiting and synchronization locking already implemented here by your blocking queue itself. You go producer
right,
produce consume. Wait some times. Oh, time is so larger. I put something. So time would be very minimum. It would be that's oh sorry one. So quickly they are producing. We are consuming, producing, consuming, producing, consuming in this way. Produce, consume, produce, consume, produce, consume. Right?
right.
Produce.
In the blocking queue, if you change to two, what happens?
This means कि producer can produce two value. Okay. So let's here change. So producer produce two, consumer consume two value. You can do
Okay.
right. Okay.
Oh, I see, I see. Yeah, yeah.
Two produce, two consume, two produce, two consume, two produce, two
Right.
consume. And even you can get a option producer produce, consumer consume. It's okay.
Yeah.
So let's try. And today we are going to out of times, and we'll continue this. Okay.
So tomorrow you're off.
Tomorrow I'll off. Next
Okay.
we'll continue. Okay.
So I'll see you.
That's great. Thank you.
Thank you. Thank you for the time. Bye now.
Bye.